Greetings, ladies and gentlemen. Thank you for joining me. In today's presentation, we are looking at this interesting topic in further mathematics, coordinate geometry. There are two keywords here, coordinate, then geometry. Coordinate means any point you pick on the Cartesian plane has x and y coordinates. Then geometry means adores both the plane and the solid shapes that we can draw on a Cartesian plane. It could be rectangle, it could be square as the case, or triangle as the case may be. So there are two things harmonized together. Let's look at the concept of coordinate geometry. Under this coordinate geometry, we'll be looking at the distance between 2 points. That's the line segment. Let me put it in brackets, straight line. Let me put it here, straight line, because we'll center our discussion on straight line. That's the distance between two line segment. That's a straight line now. Very important. Then we'll look at the midpoint, how we can find a midpoint of a straight line or line segment as the case may be. Uh, as I said, let's look at distance between 2 points on the Cartesian plane. Suppose we have our Cartesian plane as x, y like this. Okay? If we have a straight line like this, we can find the distance between, say, let's say these 2 points here, P and Q. Very important. Let's say at this P here, we have x1 and y1. That's the x coordinate and the y coordinate. Then at this point here, we'll have x2, y2. Very important. So to find the distance between these points or this line PQ, which is also known as length, to find the distance or the length PQ, let's look at, if we draw another line here and draw another line here, we'll have a right angle triangle. Suppose we extend this down here, this will be our x1. If we extend, let me put r here. If we extend this down, this will be our x2. So the distance between this x2 and x1 will be x2 minus x1. That's increase in x now. Very important. What about this here? We'll have y1 here. Then at this point, y2. Then the distance now will be y2 minus y1. Very important. Then we can use this concept to get the distance between P to Q. Very important. Using Pythagoras rule, because this is a right angle triangle, we can establish the fact that length PQ square, this is the hypotenuse now, square, will be equals to the square of length P to R, that's PR square, plus R to Q, that's RQ square. If we apply this Pythagoras rule, we'll get the distance, the formula for the distance between this point P and Q. Very important. Okay, let's move here to see what we can do. PQ, we have length PQ now, all square, will be equals to PR. P to R is the same thing as x minus x2 minus x1. That will be x2 minus x1 all square plus R to Q is the same thing as y2 minus y1. That will be y2 minus y1 all square. Very important. And to find length PQ now, let me use another. Length PQ will be equals to, we take the square root of both sides to remove this square now, to be roots x2 minus square root of x2 minus x1 all square plus y2 minus y1 all square. And this is said to be the distance between point P and Q. Very important. So this is how we come about the distance between 2 points, or the formula for distance between 2 points. And we can use this to solve a problem. Let me use this to solve a problem. So if you want to find the distance between P and Q, we use this formula. Very important. So this is how we come about the formula. Let me clean the drawing. Then we'll now look at example 1. Let's say e.g. 1, we are asked to find the distance between the line joining point, the distance between the line joining points, joining the following point, or joining the points, let's say 2, comma 3, and minus 4, comma, let's say 5. We are asked to find the distance. This distance, sometimes they can say find the length. The length and distance, they mean the same thing. Very important. It means, first thing to do, let's write down the solution. Let me define this point as P. Point P now will be 2, comma 3. And let this be Q, which is minus 4, comma 5. Very important. This is my x1 and this is my y1. Very important. This is my x2 and this is my y2. So let's use this formula now. This is the formula we have to use. We are asked to find the distance between P and Q. Very important. So let's substitute. I'm using this formula now. It will be PQ now will be equals to the square root of x2, which is minus 4, minus x1, which is 2, all square, plus y2 is 5, minus y1 is 3, all square. Let PQ now will be equals to the square root of minus 4 minus 2, that's minus 6. Minus 6 all square is 36, plus 5 minus 3, that's 2. 2 square is 4. So we have 4. So length PQ now will be equals to 36 plus 4, that will be 40. That will be root 40 units. That will be root 40 units. We can simplify this as 1 of the perfect square, 40, 40. Can we use 4? Yes, 4 and 10. You can still simplify this further by saying 4 times 10. That will be 2 root 10. We can write this as 2 root 10 units. They mean the same thing. Either root 40 units or 2 root 10 units. That will be length, the distance between P and Q. So this is the concept of distance between 2 points. Let's quickly move to midpoints between 2 points. The midpoint between 2 points now. When we have 2 points and we are trying to find their midpoints, what do we do? As I said, we are looking at straight line. Let me write it here. We are looking at straight line. Okay, we're looking at midpoints. Midpoint between 2 points. Very important. Okay, suppose we have our Cartesian plane like this. Let me draw it big, whereby we have length, let's say P, which is x1, y1. Then we have Q here, which is x2, y2. We are asked to find the midpoint or the midway between P and Q. Let it be this way, which is R, that's x, y. Very important. We can trace this line down. Let this be x1. Then trace this down. Let me pick a point here. Suppose I have something like this. This is a right angle triangle, and let's say this is R, I can trace this down, very important, and as well trace this midpoint down here. Very important. Here will be x because this is x-axis, this is x-axis, and this is y-axis. Here, of course, will be x2. Very important. This point, let me take this r in here. Here will be y1. Then the midpoint here will be y. Then here will be y2. Very important. Then let's analyze this. Uh, the distance between this x1 and x will be something like this. It will be x minus x1. Very important. Then the distance between this x and x2, it will be x2 minus x. The same thing for y. The distance here between these 2 points here, it will be y minus y1. Then this one here, this one here, it will be y2 minus y1. Then with this knowledge, we can find the midpoint. Very important. Okay? It means we can equate these two. Let me say I have S here. Here is R, and then let's say I have S here. From here, we can see clearly that, let me take it here. Can see clear that length PS is the same as length PS is the same as length S to R. S to R. Very important. Okay. What is our length PS? Length PS is nothing but x minus x1. Here we have x minus x1 will be equals to length SR is nothing but x2 minus x. Let's collect like times. We transfer this x here. We have x plus x will be equals to x2. This is minus, that will be plus x1. Let's add x plus x, that will be 2x, will now be equals to x2 plus x1. So let's divide both sides by 2. If we divide both sides by 2, x now will be equals to x plus 2, then x2 plus x1 divided by 2. So this for the x coordinate now. So clearly here, the formula now, the formula for midpoint is m into x comma y will be equals to, the first formula now will be x2 plus x1 divided by 2 comma, this is now for x. Let's look at y. So we use this formula. We're trying to form the formula for midpoint now. This is how we come about for x coordinate now. Let's move to y. Let me clean here so that we'll get that of y. Okay. If we look at this clearly, r to, let me put t here, length r to t, length rt is the same as length tq. R to t is y minus y1. This is equals to t to q is y2 minus y minus y. Let's collect like times. Y to y, that will be y is minus y plus y will be equals to y2 is minus plus y1. We can add this. That will be 2y. This will be 2y will be equals to y2 plus y1. Then we divide both sides by 2. Y now will be equals to y2 plus y1 divided by 2. This is for y coordinates. So I can write it here. Let me remove this drawing. I can write it as y2 plus y1 divided by 2. So this is how we come about the formula for midpoint between 2 points. Thank you for watching. Do share this to your learned colleagues. In my next video, we'll look at how we can use this formula to solve as many questions as we can. Thank you for watching.